So yeah, I'll go off camera then shortly, let you run the show. But if you'd like, I can keep an eye on the comments and chime in if there's something. So
Yes, please keep me in the loop with the comments.
Sounds
Okay.
good. So I will be off and mostly mute, but if there's a question or something, I'll just jump in and raise it.
Okay.
All right.
Perfect. Thanks. Okay, I'm just gonna close up a couple of tabs to clean things up. Okay. All right. So let's get started. Just to set the stage on what I'm gonna be presenting here, I'm gonna begin by illustrating the problem. So the problem is humans are on the loop. What I mean by that is whenever you're developing a system that depends on LLM agents or just LLM calls more specifically, the process by which you optimize or improve the call involves a human. And it involves a human
zoom in by one tick or two? We got some questions in the chat. Sorry to see. Awesome. Thank you.
Okay. So it involves whenever you're optimizing this LLM call, it basically is a pretty systematic process as to how you optimize the call, and that is essentially the problem. So let me just run you through it in case you're not entirely familiar with how you optimize all the calls. I'm just gonna run you through it pretty granularly. So you have the developer. The developer instantiates a series of parameters that are passed into an SDK. For example, the OpenAI SDK, which is almost like standard now, and the OpenAI SDK takes in these parameters. It takes in a system prompt. It takes in a chat history, which really system prompt is like something inside chat history. And you can also pass in output constraints like structured outputs, and I destructure this further, which I might go into in the future, which I might go into like further in this presentation, and then additional metadata / hyperparameters like temperature, top K, and so on, and also the model. And then once you've please feel free to interrupt me at any point. I would really appreciate feedback for this. So getting back into it, you also pass in the parameter of a model. All of these are very can dictate what kind of output you get from the LLM call. So you send all those parameters into the SDK. The SDK gives you an output. And then what the developer ends up seeing, I'm going to skip a couple of steps, is basically the inputs, outputs, and if you have telemetry set up, then you see that telemetry. If you have evaluation set up, then you can also explore the score through whatever metric you're using, and an exclamation if that is something that your evaluation provides. So as a developer, you're basically getting back into like the thing that I skipped. So the developer has access to the inputs, outputs, exclamation, and score. A lot of the time, people don't often. I guess in production settings, you do have telemetry set up and observability. And how that observability is set up is you basically add instrumentation over to an LLM call, which makes it so that whenever the LLM call is executed, it stores the inputs, it stores the outputs, and then in the case of certain observability platforms, you can also like in flight run an evaluation on the inputs and outputs. So the evaluation is then run against your configured prompt and the rails, which are just output constraints. And then that will produce an explanation and a score. I'll probably get into what this looks like programmatically further on in this presentation. So you have the developer. You basically run multiple instances of a call. You're going to look at all the inputs, outputs, exclamation, score, and then you're going to make an analysis and a conclusion as to what needs to be changed. That's what these arrows illustrate. You're going to be observing that, and then you're going to make changes to your outputs, and that cycle continues until you're satisfied with until you're satisfied with your outputs and or eval. So the idea here, the idea behind what I'm going to present is basically deleting this and making it so that it basically automatically updates the parameters in an LLM, going into an LLM call. So that basically sets the stage as to into the problem that I'm trying to solve. So how is this? So just to like reiterate, this is what I'm going to be presenting. So self-improving agents. It is a system built on top of observability for minimally invasive autonomous agent optimization. And from this presentation, I'm going to be running over like the theory, the technical complexities, and also the constraints. And I mean, uh, the problem, the solution, the takeaways, and then the future work. Those are the things that I'm going to be covering over the course of this presentation. Feel free to interrupt at any point. And agent definition. Oh, okay. So as I was like looking through an agent definition for the purposes of this discussion, I was looking at like Hugging Face's agents course, which I remember had a pretty good definition, but it turns out that they changed their definition of agents to like satisfy their small agents library. So it's basically deprecated. And what I was gonna put here is basically something. An agent is can create something dynamic calls, something uses for. So this is basically the agent definition I was fetching for, but they changed that to support their small agents library. Okay, so again, feel free to interrupt. If there's any questions so far, let me know. So the outline of what I'm going to be demonstrating is, I feel like to motivate the problem. Actually, I'll start with this. Once we get into the solution, I think I'm actually gonna end up running things towards the end in case I do run into any errors. But that way, I actually like covered everything I wanted to cover before I end up getting discouraged by my errors. Okay, so the problem I already illustrated below is basically we want to remove the developer from having to make these decisions, which are based off of formulaic things that are fully off of a formulaic process that depends on data that is entirely programmatically available, aka observability platforms, SDKs. Yep. Okay. So the solution. The solution is basically guided by reinforcement learning, and it is contingent on telemetry as a means to obtain the data for the reinforcement learning process. And the updates for the solution happen at test time, meaning that we're not updating the weights of the model, we are updating the input parameters. So to begin, I need to preface with reinforcement learning. So there's a pretty clear definition of reinforcement learning provided by IBM that states in reinforcement learning, an agent seems to, and I will be referring to the reinforcement learning agent as RL agent to distinguish it between what we people in AI engineering refer to as agents, which are really just grounded on the same idea, basically taking actions in an environment. Okay, so in reinforcement learning, an agent learns to make decisions by interacting with an environment. It is used in robotics and other decision-making settings. Okay, yep. So the core components of reinforcement learning are. Oh, and also I should be sharing this. Right? Just give me 1 second. Anyone in the project? Anyone can view? Okay, copy link. I'll share this in the chat. Definition for private agent. I actually don't know what this is. Okay, but I'll carry on.
Sorry, yeah, there's a lot of chatter going on about the definition of agents that is irrelevant. So I haven't been mirroring it to you, so don't worry about it.
All right, yeah. So I shared the Figma. It basically contains most of my work designing this project, um, and there's also links inside of the blocks if you're interested in like digging deeper. Okay, so in reinforcement learning, you have these components. You have these like essential components. First, you have the policy. Um, Policy oftentimes denoted as pi, which shows how agents take actions. Um, and like formerly, you used to have like a queue table, which basically just mapped out an agent, an act, basically mapped out a state to an action. Um, so if you wanted to go in a straight line to the right, no matter what state you are in, it's always going to tell you to like turn right. I could kind of illustrate this, but that's like getting too deep into it. Nowadays, you use deep bar L and or other methods that I'm not familiar with, other more advanced methods. I mean deep Q learning. So then you have the state, which is all inputs available to the agent at an instance in time. Um, and then you have the state space, which similar. Then you have actions, basically something that's going to transition you from the current state to some other state. Then you have an action space, which illustrates all possible actions. Then you have an observation, which is the combination of a state and action pair, and a trajectory, which is basically a series of different state action pairs, basically illustrating the path that was taken by an agent. Um, then you have the reward, which is the immediate benefit at a current state, and then value, which is the long-term benefit of being at a state. Yeah, at a state. The value uses this thing called the Bellman equation, which incorporates like future states into it, potential expected future rewards. Um, yeah, and then you have the environment, which is what the agent interacts against. So that's basically setting the stage as to like the important components of reinforcement learning. Then we have the exploitation trade-off, which is very important in reinforcement learning because, for example, in this image, um, if basically a cheese equals some reward, then the mice will need to explore, meaning it will need to move in order to obtain some reward. Once it obtains that reward, it can choose to exploit it. So if it turns to the left and it gets that one reward, and you're like maximizing for exploitation, then it will always turn to the left to get that left cheese. But imagine that the cheese, the like stacked 3 cheeses on top are like 100. Then you're gonna want to explore beyond that initial like ring of cheeses, and in order to like potentially discover that you can actually get a lot more cheese if you explore much further. Yeah, and then finally you have online versus offline reinforcement learning, which is the difference between them is offline. You basically cannot interact with the environment. You just have a collection of data that you're going to be working off of. So, and did I say offline? Well, whatever. Offline, you cannot interact with the environment. Online, you can. So basically, you can perform an action on an environment. It produces the new state and reward, and then the cycle continues until the trajectory is complete. So yeah, those are the basics on reinforcement learning. I will tie those into how they actually fit into the current solution once I get to it. Do we have that? Is there any questions regarding this? Okay, I'll continue. Okay, so for another thing that the solution is contingent on is observability. So for observability, there is there basically what observability is being able to track the state of your system. This can be either through metrics, this can be through traces, this can be through logs. Um, and I'll get more into that in a moment, but options available include, well, OpenTelemetry is really just framework for how you should collect, generate, export, and collect observability data. Then open inference is it's basically defined here. It's a what do you call it? It's basically a means for collecting telemetry data in a format that is more that like favors AI AI or well LLM AI agents, so that it basically captures like the chat history in form in a in like a for in a way that is applicable to like any LLM agent provider. There's a word that I'm just like it's completely going over my head. But yeah, it's basically built on top of the open telemetry. It's just a formatting for collecting telemetry data on AI agents or just calls to AI models. Then you have observability. Then you have other observability tools and platforms. Prometheus is a popular open source tool for monitoring. You have Datadog, that is a full stack observability. Langsmith, weights and biases, and Arise. Yeah, so those are that's observability. This solution is built on top of Arise. So the Arise offers two products. One is their platform. The other is their open source their open source solution, which is called Phoenix. And the solution specifically works on the platform. So yeah, what does it actually use from Arise? It uses like why do I end up using Arise instead of like just building my own like data store on OpenTelemetry data? Well, open telemetry and open inference data. Well, that's because they basically abstract a lot of the collecting, a lot of the generating, exporting, collecting of data. So you have traces that you end up producing, which in our case was basically this step. Whenever you're making a call to the provider, the traces being produced are the inputs and outputs, and then you have the evaluations, which I showed later. They do offer support for tracking evaluations, which are actually stored in the traces, as far as I remember. But yeah, so how they generate the traces, they generate it through instrumentation, as I showed before in the example, and then how they export it is through a list of. They export it through. Okay, I think at this point it might actually be worth clicking on some of these links. They exported through their SDK, so that's abstracted for you. Exported from your local machine over to their platform for storage. And I'm gonna click on this link and just show you what this actually looks like. So for tracing, you have these tracing integrations. We're gonna look at OpenAI, and basically all you have to do is just configure this tracer provider, and then instantiate this this instrumenter, which will basically, what it does is it looks at your code, and this finds a function that has like the same signature as the OpenAI SDK like chat completions, and basically it wraps itself around that function. So it's pretty nice, although pretty opaque as to like how it actually works. Like when it the first time I used it, it kind of caught me by surprise that it was working. But yeah, so that is how you set up the instrumenter. And in order to like retrieve that data, should be somewhere in here. Oh, I all the way up. I think it might actually not be shown here. Tracing. Oh, there's also a way for you to create customized tracing, but that is the more freedom I give the users for this solution that I'll show in a moment, the less the more complex like providing the solution is, right? You need to constrain like your users in some way in order to like actually get something shipped. So I can't really find it here. Hopefully, tracing. Okay, and offline evaluations. That's where I found like how you can pull from the SDK. So inside evaluations, you have quick evaluation. Okay, well, while we're at evaluations, I'll also showcase how you can actually save evaluations. And one way is basically to use these online evaluations. How to evaluations, please. There you go. So this is one way how you can basically add evaluations to your whenever you're making calls to an LLM. You basically configure this on their platform, and what it uses under the hood is this thing that is shown in the offline evaluations. So yeah, they basically provide like a no-code way to add evaluations so that in flight, whenever the trace is being sent to their platform, it basically runs the evaluation on that trace, and by the time it like reaches the platform, it already has an evaluation built in. That is the online evaluations. If you do not configure that, you also have the option to do offline evaluations, which will begin by you exporting from their platform in like basically calling the traces over to your local machine through this function called export module df. And this will basically get you the traces in this format that is shown here. And this is, I'm pretty sure, their open inference, through their open inference. Okay, I gotta figure out what this word is. Open inference. Oh, and in fact, actually, that's open telemetry. In what case? Oh, yeah. Sorry. It's a convention. It's a convention built on top of OpenTelemetry. That's what I was getting at. So Open Inference is just a convention built specifically for GenAI. Okay, so moving forward. Okay, yeah. So you get that information. You get the traces. You basically run them against this this eval function that you're configuring here, and then you basically upload that back into the platform so that it is stored, so that it's persistently stored. Okay, so yeah, that is how observability works at Arise. I will show code for that soon. But okay, the solution. How can you actually automate things? So I think I'm going to begin with the constraints. There's a lot more constraints than what I wrote here, but these are the top ones that come to mind. And also the constraints, the idyllic constraints, because there's a lot of additional constraints which are just related to bad coding, unfortunately. So the current constraints are dependency on the traces that dependency on basically the Rise SDK. This is not configured to support any other observability platform, but it could very well do that. So another thing is you cannot have any intermediate steps between receiving the telemetry data and generating the eval. So there, like, let me show you what that actually looks like. I'll zoom in on this. That's maybe too far. Let me know if this is actually legible. Okay, example. Okay, so this is basically me utilizing their evals. Me doing an implementation of offline evals. So what is going on here is I'm instantiating the Rise client basically with my credentials. then I configure the eval template. Basically, this is LLM as a judge, just as a reminder. This is LLM as a judge that produces basically a score based on how good the formatting is. And it has basically a discrete scale between 1 to 5, where 1 is very poor formatting consistency, and 5 is very consistent formatting. By consistency, I mean that the user inputs some text, the LLM, this is just a toy example where the user inputs some text and the model is supposed to rewrite it in a way so that it preserves the formatting. And so I run it into this eval, into this LLM classify, but unfortunately, I think I might have removed this. But at some point, I was adding additional pre-processing so that I would not have to, for this reason, for this reason here. So at the moment, I'm basically passing the entire, I'm passing the entire chat history into the LLM as a judge. Ideally, I would want to pass in only a single, only the current user message, not the system prompt. For it, because the rest is like arbitrary information that it doesn't need in order to compare how consistent the formatting is with the original text to the rewritten text. But unfortunately, because of limitations, I've had to resort to. So, in order to eliminate the intermediary steps, I basically have to make a compromise by passing all the the entire chat history. Ideally, I would be able to replicate the entire transformation flow between retrieving the telemetry data, transforming it so that it fits best inside the eval template, and and evaluating it. But due to constraints, I kind of need to work in a way so that it doesn't allow you to make any intermediate transformations. Okay, so that was a big tangent, I think. Then you have it must use instrumentation which follows open inference. Yeah, so that's the other thing. Whenever you're creating an evaluation with LLM as a judge, it is expecting the data inside the trace to be of a certain format with certain keys. So if those keys are not found, then it could break down your evaluation. So for example, this is a key, which as you can see, this is basically this is a list of traces that I've been referring to without explaining it. So this is one of the keys inside the open inference. In like open inference, following open inference conventions, and yeah, just to like illustrate things. Okay, so moving forward, I have. Okay, and then finally, just to wrap up the makeshift the ad hoc PowerPoint, let's tie it into like what is the relation between my current solution and RL. And I think I'm going to begin with this RL by analogy. So in this system, in the problem statement that I illustrated before here, they have that in the back of your mind as I run you through this. So the policy, you can think as the system as a whole, like, or quote unquote agent. If you're thinking of like, for example, let's think, what is it like a, let's think of cursor. Cursor is pretty complicated, but we'll go with that. The entire system as a whole, you can think of cursor as an agent that basically takes in your entire code base and then either and predicts like what code should be generated according to some user inputs, and if you basically pass it some input, it's going to want to explore some files and then provide some code changes. So those are like two different tools. Yeah, so we'll just draw it out. Okay, so you have the cursor agent. This is basically like the start. Then you have two potential paths it can take after what basically this is the user. The user basically gives it some command to cursor to change a piece of code. So cursor, if it already like knows the piece of like, actually, let's just delete this. The first thing it's gonna do is it's gonna basically read a file. We'll call it read file, and then it's gonna determine whether or not it should basically read a file. Basically, the next step is another agent that determines whether it should read another file or it should transition over to writing code. We'll just say writing file for consistency. Okay, so this is just the example agent I will use for the solution. So pi is basically this entire system. This entire system you see here would be pi. This is like the policy. For example, if you're found in this state, then the policy is going to be like 100%. You're going to go to read file. If you're at read file, then the policy would be like 50, 50, 50. You either read another file or you write a file. Here would be like 100%. All right. And then the state is basically all inputs into the LLM call. So basically, the state at this point would be just like the original input message, just the user input, and then the state at this point would be user input plus whatever additional thinking, user input plus cursor input if needed, plus cursor input. So that would be the state. Then you have the action. The action is basically the transition where it decides whether to go back to like reinforce back to reading a file or writing a file. Then you have observations. The observation is just a combination of state and action. Trajectory doesn't really change. Reward is based off of the evaluation. So if you're satisfied with the right file, let's just say the reward only happens at the very end. If you're satisfied with the reward file, then it'll give you a score of like 1. If you're not satisfied, it'll give you a score of 0. So R is equal to 1, let's say. And in that case, let's just say the path was basically, it goes from C to RF, back to RF, and then WF, and that basically resulted in a reward of 1. If it only reads a file once, it gives you a reward of 0, something like that. So yeah, and the environment is okay. I guess the environment is just like the knowledge of the models that are running this. The environment. Well, okay, I might have like tripped over here. I don't think the environment really captures it, but okay. I'll just move on. Okay, so how does the system actually work? So you go into this trajectory, and well, you have the developer. They have configured this. They have configured this. They have configured this wrapped eval, which is like an abstraction. So in order to like basically get the self-improving agent system to work, you have to wrap. You have to use this evaluator abstraction. That basically constrains things in a way that I can actually reproduce them for validation purposes. So that is shown here. And what that actually looks like in code is, I have this here, eval pipeline, this eval pipeline. So this is basically very similar to what you saw before. It's just using eval run pipeline, which takes in the LLM classify function. And in fact, I'll just run this. So I'll get this thing going with export arise model ID, copy, paste. So I have this arise model ID. We're going to call it latent space. This is basically going to configure the this space that we're going to be using inside arise. So basically one of the projects. And what we're going to do is run Python 3. We're going to generate a series of samples first. Yeah, so we're going to basically run this file, which is basically just asking ChatGPT to rewrite. Note that this is instrumented here. I'm basically just going to ask ChatGPT to rewrite 6, or we'll do 3. To rewrite 3 different texts with and explicitly, as I mentioned here, with completely different formatting. So the idea here is just I want it to fail the evals. So I'm gonna have this run Python 3 so agents, see the examples 3. What is this called? It's generate sample. Okay. Samples. Okay. So this is running nice. Okay. So this project, this space is going to take a second to boot up. So in the meantime, I'll just run through the eval pipeline. So basically, going back to the Figma, where we were configuring, you're basically configuring this this self-improving agent system, and what you need to do is you basically, whatever you had working for eval, you're just going to wrap it inside this wrapped eval. So let's see if I can at least see the new project. Okay, latent space. This should be loading. Okay.
There's a question here about how do you get visibility into the training process? Like, are you looking at the LLM judge scores, or like what's going on there?
Yeah, so visibility into the training of what? Like the training of improving the parameters? So assuming it is that you're talking visibility into the training of the parameters, improving the parameters, is I'm basically, and this is ironic because this whole thing hinges on Arise, but I'm basically just logging. This is how I get visibility, validation. This is what tells me like the baseline of how the samples are performing. So basically, we're gonna be right now. I just ran 3 samples, and in a moment, I'm also once the project is ready, I'm gonna run the evaluations, and that's gonna tell me how effective the current samples are at the baseline without any modifications to the inputs, and that will be visible once this product is loaded. Not sure if that answers it, but let me know if it didn't. And yeah, once I do upload, sorry, not upload. Yeah, once I do upload the evals, and once I run this this update step, then it will hopefully become more clear. So let's see where was I? Okay, yeah, the eval pipeline. This eval abstraction over LLM classify, which was what the hypothetical user would have been using before. So you basically do that replacement at this step. Sorry, at this step. And then the other thing that needs to, actually that's the only thing that needs to happen. Yeah. So there's one more thing to note here, which is this SIA like state directory. But I'll show that as it actually becomes relevant. Okay, so what happens is you have users or you have a test data set, and then you basically run that test data set against your platform over and over again until you get like, actually this is not a trajectory, these are just like different, until you have like a batch of inputs. Yeah, so you just collect data for, you just collect data off of usage for your LLM. Yeah, so data that will be used for training, basically. You can think of this as this step as just training data. This is just training data. And then we begin with the update step. But first, I would like to run the eval. So did we get this thing loaded? Perfect. Okay, so these are the three samples that we just ran a moment ago. Arise. This is where open inference comes into play. I'm sure through their conventions, they know that you're going to be passing something in some format, so that it is basically able to destructure the call that you made to the LLM. So here, this is the exact same system prompt that I passed in over here, or yeah. So there, it's matching, and then it's also matching the other inputs that I passed in as the user. So it has, yeah, and then that'll produce the rewritten output, which should be a different format. Okay, apparently not the first one, but and this will actually be shown in the inputs, I hope. Yeah, this one here is a very different format. It has like bold. It has like the title. It has bolded like initial first couple of words and at the start of the paragraph and so on. This one basically has no formatting whatsoever other than paragraph. Okay, so that's in. Now we're gonna run Python 3 eval pipeline. And these are all examples. I'll share the repo in a second. So Python 3 eval pipeline, we're gonna be, okay. Yeah, we're basically gonna be running the evals. This should be abstracted into the project. So if I reload this, hopefully the evals will appear. Someday they will appear. We'll get back to that. But in the process, like the reason why I created this abstraction is because of this. So that I can actually capture the the information going into the eval, so I can replicate it later for validation. So in this case, oh, and that's my space ID. If anybody's interested in using that, and yeah, my model ID. So this is the important information. Like I captured the rails. I captured the template without it actually being instantiated. You can probably see attributes right there. It's not actually instantiated, it's just the template itself. And this model thing is basically overwritten eventually. And yeah, so I basically capture the arguments passed into two separate things because I do want to keep things. I'll show you. So this run pipeline has basically two steps. One of them is implied. The first one is when you get the data, the traces from telemetry, you're probably gonna want to get them from one specific project, not just arbitrarily choose a project. The other thing is you probably want to indicate the start time and end time for the traces. That way you can be specific about which traces that you want. And this is something that I kind of want to replace with just more conventional versioning. But for the time being, this is what I had to work with because of the time constraints. So yeah, I need to capture this information in order to reproduce it later down the line. And these are the evaluator the evaluator arguments that you're passing. And here is the evaluator function that you're using. That actually is a bad code constraint, which is it only supports LM classify at the moment. But and it also has like the evaluator name so that you can manage multiple evaluators at the same time, and so that you can basically learn from multiple different evaluations. So yeah, that is the motivation for the evaluator wrapper. Okay, so now we can actually get to like trading it. So Python 3 workflow, something like that. Okay. No telemetry found. This is probably, yeah, okay, this is because I'm using the wrong time, the wrong time window. So I'll actually update workflow. I'll update the time window for this to be basically and date, whatever time it is now, date time. Date time now. Yep. Okay. So, oh, and hopefully we have our evals here. There we go. Okay, so now we have the evals actually uploaded into the space. You can see here. I don't know if I can click it. Okay, well, if you look at the trace, this was the one that had pretty consistent formatting. If you look at the evaluations, it gave it a score of 4, meaning formatting was pretty good. And in this one, on the other hand, where it had very different formatting, it gave it a score of 1. Okay, so now it's actually running the update step. And what's going on in the update step? So while we wait, and also this was the small hack I had to do, but we'll get back to this once it's complete. Okay, so what's going on in the update step right now? You already have this data collected. This is equivalent to what I have in here. Now you want to be able to extract that data. So the developer, what you're going to need to do to configure to run this eval step, and I'll show you the actual code. Pretty simple, but that's kind of like a limitation as well. You basically just configure the time window, and you basically, yeah, you're configuring the time window, you're configuring what evaluators you want to be testing against. So right now, all we care about is the formatting classify, and then the model, which is just the model that's being used for evaluation, the evaluator function, LM classify, and then the limit on how many samples we actually care about, how many samples we want to look at. Because, for example, if you're, well, that's kind of related to like versioning. I don't know, just to give the user control over how many samples they want to include into their update step. That's basically the point of limit, and the point of the window, like the start time, end time window, is to select like a specific time where the traces were actually consistent. Because if you were changing the parameters if you're changing the parameters to your trace constantly, then it's really of no use to suggest any consistency between them. Like what I'm trying to get at here is if you keep like under constant constant parameters, you want to be able to run that against several under constant parameters. You want to run that against different test samples in order to get some good variance on how your LLM call is how it's performing generally. So that's the point of the time window, is just to get that consistent, get that portion of time where it was behaving consistently. Yeah. So moving forward, you have you also have like checkpointing. so that I can actually, so the point of checkpointing is we can see like the updated action somewhere here. Checkpoint. Okay. Yeah, so this is the updated action. It should basically, again, this is a toy example. I was originally telling it, make sure that the formatting is completely different. So here what it's suggesting instead is maintaining a moderate level of formatting consistency with the original. So whereas my original system prompt was completely running against my my evaluator, now it's like kind of converging it so that it better satisfies my current evaluator. Then we have a couple of snapshots. I don't know if I added this as a configurable like parameter, and this is irrelevant. Workflow example, get rid of it. Okay, back to the workflow example, absurd verbose. Okay, we did not configure that. So the snapshots is basically how it's, what are the outputs of the evaluator? These are the original outputs. It got 411, as we already covered before. And these are the new inputs, which, so this is interesting. I'm not sure if this was actually, and this was one of the bugs that I was dealing with, which was it wasn't actually like looking at different traces. So if we look at back to the platform, we should see a lot more traces in here. So we have 3 more traces on top. Completely different formatting. So this is, oh yeah, so this is the baseline evaluation. This was what we saw here. So basically this maps out to the baseline evaluation, these 3 traces, and then these 3 traces should map out to the updated updated trace. Sorry, the updated, the calls to the LLM with the updated action, with the updated system prompt. So as we can see here, this should be consistent, and the next 2 should be generally consistent too. So this is consistent as well, and this is consistent as well.
We've only got about 5 minutes left, so I think you're getting close to wrap up. But
okay.
Let's make sure we do that.
Yep, noted. Yeah, so that is basically what it does. Unfortunately, like my states directory did not actually capture the updated outputs, but the formatting, like the actual checkpoint of the you can think of this as a patch where it basically updated the system prompt. This actually captures like the problems with the original system prompt and tries to correct them. Yeah, so if that's basically how it works. The idea here would be that the user will then be able to just copy this over and paste it over to the original LLM prompt, to the original LLM call parameters. Yeah, so that is that's like future work that would be happening from here is 1, having versioning, having actual like clean versioning. 2 is like careful state management, like kind of just like built out the state management as needed, and finally expand to multiple time steps, because right now it's only operating for a single time step, which is 1 LLM call. Expanding it to multiple time steps and being able to run like Monte Carlo search would be very useful, I believe. Okay, so that's basically all I had to cover, all I wanted to cover. Is there any questions? Oh, and also like the link to the GitHub is, I'll share that. But yeah, any questions?
See, Zach has a question about what follow-up experiments are you going to pursue on this next?
First I need to get it working. There's gonna be like a heavy refactor. But yeah, I want to see how, like, right now I've built it so that it only updates the system prompt, and also the model. That was just like for exploratory purposes. But ideally, what I want to do is give it the ability to change anything in the parameters that you pass into the LLM call. That's step one, and explore that with an actual like valid data set. Then I want to expand to like multiple agents, as I mentioned, multiple LLM calls, and that can be very tricky because there can be like an infinite amount of intermediary steps. So being able to like tap into the environment directly, like for example, if you're running cursor, like the lines, if you're the team behind cursor and you're trying to use this, and you're trying to use this, then the lines here, like it's usually I can guarantee you that their system does not consist of literally one agent calling another agent directly. There's probably a lot of pre-processing that is happening here. So I would need to be able to like inject something like the updated actions at a specific intermediary point. So that can get really complicated. Yeah. So I hope that answers it. Graph.
All right. I don't see any other questions, and we are right at time. So let us wrap. Thank you, Sebastian. Appreciate it. And I think you already posted most of the stuff here, but anything else you want to post in the main AI in Action Club channel as well, I'm sure folks will appreciate.
Yes, we'll do that. Okay. Thanks, guys.
Cheers, y'all. Happy Friday.
Feel free to let me know